Hi, this is our second video on the EzRover. And in the first video, we gave a quick tour of the web UI that is hosted by the rover itself. And we talked about how to drive the rover using turtle mode. We also saw that when we did that, we looked up at telemetry here, and we could see that one motor was driving at a slower speed than the other motor, even though both were getting the same PWM value. So the rover speed telemetry that comes back from the rover and is shown here, the yellow line is PWM, and we're only seeing one because we're sending the same exact PWM to each wheel, and therefore one line draws on top of another, so we only see the one line. But because the motors themselves are not they're cheap motors, and they respond differently to different power levels, which is what the PWM is. We're sending it a power level. They respond differently, and so one's actually going at a different speed than the other one. And we can see the left one is at 46.1, so that's that higher, lighter color value up here, and the right one is at 40.8, and those are in centimeters per second, because that's how I've when I configured my rover, when I built the C++ code, I measured the wheel in centimeters. And so all my numbers in centimeters per second. And so here the right wheel is moving slower than the left wheel, and what that results in is, if we look at the pose is showing the position of the rover over time. We can see that it makes it drive in a circle. Now, what you'd really want is if you said, hey, drive at 0.9 speed or 90% of maximum speed. I mean, generally speaking, you want the rover to go straight, right? That's what you think should happen. But because the motors respond differently to different power settings, it's not going straight. It's driving in a circle because one wheel is turning faster than the other. But we can rectify that. We've built into the rover is a form of closed-loop speed control, where you can command each wheel to drive at a certain speed, and then in software it will actually look at the encoders that are attached to the wheels and look at how fast the wheel is actually spinning. And if the wheel's spinning too slow, it will increase the power to that wheel. And if the wheel is spinning too fast, it will decrease the power to the wheel. In that way, it tries to keep the wheel at the power that you asked for, also called the set point, or the speed that you asked for, also called the set point. It tries to keep that speed constant by looking at what the wheel is really doing and changing the power level to match that set point that you've set. So in order to make that work, we have to calibrate the rover. And so this is a basic function that you're going to be doing all the time. And you probably want different calibrations for different settings, for different surfaces. If you're driving in high pile rug versus in your garage, versus right now I have the rover suspended in a box so its wheels aren't touching the ground at all. You're going to require different calibration settings for these different environments. So let's talk about how to calibrate it. So if you remember, prior to turning on calibrating and turning on speed control, speed up here really means the percentage of the maximum PWM value. And the maximum PWM value is 255. So this ranges from at 1, 255, and at 0, 0 PWM. So what we want to do is we want to calculate the left and right stall values for the motors. And what the stall values are is they're the first value at which the motors move consistently. So if I was to command it with that much power, I know that the rover's going to move. And below that, the rover will stall. It will either not move at all, or only maybe sometimes move and sometimes not move. So we're going to treat everything below the stall value as essentially 0. Because we can't reliably get it to move. So we want to calculate what that value is. So we're going to do we're going to do a little software thing called a binary search. So we're going to put it at exactly half of the PWM value, and we're going to try to make this thing move forward. So let's clear. We can clear our pose too. We're not going to be using the pose, but so what we're going to do is we're going to try to make the motor move, each wheel move. And the important thing here is we've set these stall values right now at 0 because we haven't set them yet. So we're only controlling speed right now via this range value. So let's move the EzRover, and it's not moving. So it's just the both motors are just kind of whining because we haven't given them enough power to move. Okay, so we need to give them more power. So let's move halfway between 0.5 and 1, which would be 0.75, and try that. And now try moving the motors, and they are actually both moving. So we can see that up here, they're both moving. Okay, they're moving slowly, but they're moving. Okay, so now let's see if we decrease it, if we move it between 0.5 and 0.75. So that's about, what, 0.63. Let's see if they'll move now. No, they're both just whining. They're not moving at all. So make that clear. I'll clear that. You see, they're not moving at all. We're not seeing any speed. Okay, so 0.63 is not going to do it. Halfway between 0.63 and 0.75 is about 0.69. Let's try that. Nope, they're both still just whining. Okay, so midway between 0.69 and 0.75 is about 0.72. Let's try that. They're both still just whining. So let's try 0.73. Okay, I hear one of them moving and one of them's whining. So they're not both moving. So we're going to move it up a little bit. Remember, we're trying to find the minimum speed, the minimum power level at which both wheels will move consistently. So right now one of them's moving, but one of them's not. So let's go to 0.74. And same exact thing. You can see up here the right wheel has a speed, but the left wheel does not. And so this should work for us because that's where we were the last time, right? There we go. They're both moving. All right. They're moving at slightly different speeds, of course, because we're still in the middle of calibration. So let's let them run a little bit. Now let's let them stop them. So you're going to want to write this number down. 0.75 is going to be the stall value. And we're going to use the same stall value for left and right. So stall, left, right, 0.75, 0.75. Okay, I just wrote that on my little pad. Okay, and then now let's move on to the next tab in the rover calibration panel, which is the speed panel. And one of the things we want is minimum speed for left and right. Well, we just actually calculated that, right? So we got the rover. We knew at 0.75 was the first time we got them both to spin at the same time. We let it drive for a little while. This scale up here represents 10 seconds. So we let it drive consistently for 10 seconds. And the bottom of the graph will show us what the actual average speed was during that period. So for the left wheel, it was 27.4. So that's our minimum speed for the left wheel. So the minimum speed corresponds to driving at the stall value. So left is 27.4. That's for me, that's in centimeters per second. And the right was driving at 25.7. I wrote those two values down. Now we're going to calculate the maximum speed of each wheel. And how do we do that? Well, we just give it maximum power, and then we drive. And we drive for 10 seconds till we get enough data. And there's our telemetry up here. And we can see we're calculating speed. Now we have 10 seconds of data, so we can stop. And if we look here, our left wheel was driving at 57.0 centimeters per second. So let's write that down. That's our max. And 52.2 for the right, 52.2 centimeters per second. So let's write those values in here. So 57 for the max for the left wheel, 52.2 for the max for the right wheel. And remember, I wrote this down, it was 27.4 as minimum speed for the left wheel, and 25.7 as minimum speed for the right wheel. 27.4 minimum speed for left, 25.7 minimum speed for right. Okay, so now we've actually filled in. Let's move this. Remember that the other thing we want to do now, after doing all those, this is the last thing we actually do, is set these both to 0.75. That was our stall PWM that we had calculated up here. And now we can turn on speed control. And now that speed control is on, we've just sent all this calibration data to the rover. So now the rover has enough information to actually control the speed of each wheel. So now with this turned on, this range value is no longer means PWM. It means the value between our minimum speed and our maximum speed. So 1 is maximum speed. 0 is 0. But just above 0, that's 0.2 of the min to max range. So if we go, remember we did 0.5 before and it didn't move. And now it should move. So let's clear that. And let's clear our pose too. And we'll go back and we'll see if it's driving in a straight line. So let's go at half speed. That's halfway between our minimum speed and our maximum speed. So let's try that. And by the way, when the rover decides what's minimum speed and maximum speed, it wants to have both wheels operating within their operational range. So for min speed, it's going to pick the maximum of these two values. And for max speed, it's going to pick the minimum of these two values. That way, both wheels are always operating in a range where they'll move correctly. Okay, so let's start the rover moving. And here we go, we're moving. Now look at the speed. Now look, they're both hovering around. Green is our target speed. That's what that line is. And they're both hovering around that target speed. But look at now the PWM value. It's not the same value for each one. We're modifying the PWM value a little bit over time to get these things to hover around our current speed. Now let's look at the pose. Oh, well, the pose is not quite straight, but it's not a circle either. So it's going in a flattish line, and you can see the value here is not that far away from 0. So it's not perfect because you can see the speeds are oscillating a little around our set point, and it's particularly important early on when you first set these things. If there's even a slight difference in speed, it'll cause a little bit of curve. But now look, as we drive over time, that's a pretty straight line. It's driving pretty straight. And so that's what rover calibration is all about, so we get enough information for the rover to figure out how to command each wheel to go at the speed that you set. Now let's set the speed now to, and let's look at those speeds. So those speeds, remember we were at 0.5 is what we had set the speed to be. And so the left is at 39.7 and the right is at 39.9. So they're both very close in speed. So let's call it 39.8. And our maximum speed would have been 52.2 and our minimum speed would have been 27.4. So if we find the difference of those two things, is 24.8, and if we take half of that, that's 12.4, and then if we add that back to the minimum, which was 27.4, we get 0.89, 39.8, son of a gun. So 0.5 is halfway between our minimum of 27.4 and our maximum 52.2, and that should be 39.8, and look at that. You average those two, and it's 39.8. So that's what speed control is all about. It's about calibrating the rover, so now we can command each wheel with speed as opposed to just raw PWM. And that's really important because now that we can control the speed of each wheel precisely, now we can do things like turn, and we can command the rover to do higher level operations. And the first one we're going to talk about, which will be in the very next video, is this go to goal behavior. So I hope you like this video, and we'll see you in the next one.